Hello and welcome to another case study of Net2Plan. Throughout this video you will learn how to execute algorithms using the time-varying traffic simulation tool. You will also learn how these algorithms are coded, how to modify them to add new features, and how to create new ones. First of all, open Net2Plan, then click on Tools, Time-varying traffic simulation. If you want more information on how to use this tool, please watch the video case study time-varying traffic simulation. In this video, we will focus on the execution controller feature. In order to perform a simulation, a network design must be loaded first. This design must have at least nodes and a set of demands. To do so, just click on the Load button, and we will use one of the network topologies included in Net2Plan as examples. Particularly, we will use the NSFNet complete. Just click on Open, and the design will be open, as you can see on the network topology panel. Before proceeding, I will explain how the simulator works internally. At each temporal instant t, the simulator works in discrete time. The kernel will request new traffic demands to the event generator, also called the traffic change generator. When those new demands are generated, they will be sent back to the kernel, and then the kernel will call another algorithm called the event processor, or allocation algorithm. Based on these demands, the allocation algorithm will perform some actions. Those actions are then returned to the kernel to be processed. Once processed, the kernel will update the network state, collect some statistics, and it will advance the clock 1 unit and start the cycle again. This will repeat until the simulation is stopped. Back to Net2Plan, click on Execution Controller, and you can see on this panel the simulation parameters. These are the name of the parameters, their default value that can be changed before the simulation begins, and the description of each one of these parameters. For example, we have the refresh time. That's the refresh time of the panel text in the simulation controller. In seconds, we will change it, for example, by double-clicking and setting it to 3. You can also see, for example, sim events. That's the total simulation events. If it's set to -1, the simulation will continue until it's stopped manually. The same thing with sim time, the total simulation time. It will again, if set to -1, continue until the simulation is stopped manually. You can also set the start time, that is the internal time of the simulator, is set to 12 hours. You can see, for example, the time granularity in seconds. That is the minimum time between traffic changes, 5 minutes internally. And once we have set the input parameters, we will proceed to select first the traffic change generator. We will use this one. Several algorithms are included in Net2Plan for you to use, and we remind you that since Net2Plan is open source, you can download the source code of any of these algorithms at the website net2plan.com. Once an algorithm is selected, you can see here a brief description about the algorithm. This one updates the current traffic demand volumes at each time slot using a random Gaussian model of mean value equal to the original offer demand volume and a coefficient of variation given as a parameter. Any input parameter that the algorithm may have is shown here. Again, you have the name of the parameter, the default value, and a brief description of each parameter. Now we'll select the allocation algorithm. Again, several algorithms are included in Net2Plan. We will use the basic traffic allocation algorithm. This simple algorithm will try to allocate the traffic over the existing routes, and link over subscription may happen. It has no input parameters. Once the simulation parameters are set and both algorithms has been chosen, we will proceed to run the simulation. To start the simulation, just click the Run button on the simulation controller panel. Now the simulation is running, and the information displayed on this text panel is refreshed every 3 seconds, set by the refresh time parameter. At any moment, you can pause the simulation, and you can see, for example, that it has simulated 1 day, 23 hours and 5 minutes. But the real-time simulation or the CPU time has been of 20 seconds. And during this time, 566 events have been processed. And you can see, for example, the last actions performed by the allocation algorithm. You can pause, continue again. This will unpause the simulation and let it run again. If you want a more detailed control of the flow of the simulation, you can use the step button. The step button will just test one event and then pause the simulation. For example, we have processed right now 704 events. If you click the step button, it will just process one event at a time. At any moment, you can click on Simulation Report, then Update, and you will see a report containing the collected statistics of the current simulation. You can also click View Navigator, and since the report is generated as a HTML file, it will be opened on your default browser for better reviewing. Under the View Current State tab, you can see information about the current state of the network at the moment of the simulation. For example, you can see the nodes and the ingress and egress traffic of each one. As the simulation runs, you can see that these two values vary over time. The same thing for the links. You can see the capacity, for example, of all the links. Since Net2Plan and its algorithms are coded in Java, you can use any IDE to perform the modifications. In this video, I will use Eclipse because it's a well-known developer tool, open source, and free to download. First, we will create a new Java project. We will name it, for example, Chambering Algorithms. It's important to note that in order to compile and execute algorithms in Net2Plan, you must use the Java SDK version 7. Once the project has been named, we will click on Finish, and the project has been created. To download the source code of the algorithms, or even the source code of Net2Plan, go to the website net2plan.com. We will go to the code repository section. We will browse to the time varying traffic simulation and first traffic generators. You can see here the name of the algorithms and the description. Just right click on the algorithm, save link as, and locate your project folder, the SRC subfolder of your Eclipse project, and just click on save. Now we will proceed to the allocation algorithms, and we will do the same thing with the basic traffic allocation algorithm. Just click on save link as, your project folder, SRC subfolder, and click on save. Once both algorithms are saved, we'll go to Eclipse, then refresh. And as you can see now, both algorithms are included in your project. If you open both algorithms, you can see that they contain a lot of errors. This is normal. This is because Net2Plan uses some external libraries that have not been included in the Eclipse project. To do so, just right click here, select build path, then configure build path. Now click on add external jars select your Net2Plan folder installation and then this subfolder called lib. As you can see, there are several .jar files included here. Just select all of them, click open, and then OK. You can see now that almost all the errors have disappeared from both files. Just this one remains. That is because we have not included both algorithms under the appropriate Java package. This is an easy fix. Just remove this line from both files and save all the files. And as you can see now, no error appears in any of the algorithms. First, I will explain the code of the basic traffic change generator algorithm, and then I will perform some modifications to add new features. You can see that this file contains only one class, which implements the iTraffic generator interface. To better understand the code of Net2Plan, we recommend that you open the Java doc that is included in every Net2Plan installation. To do so, open your Net2Plan installation folder, then locate the Java doc subfolder, and then open the index.html file. As you can see, it has opened the Java doc. We will locate now the iTraffic generator documentation. This interface must be implemented by any algorithm that wants to be executed as a traffic change generator on the time-varying traffic simulation tool. It contains only 4 methods. The first one is called getDescription. It just returns a string containing a brief description about the algorithm. This description is then displayed on the Execution Controller tab in Net2Plan. We will see about this later. The second method, called getParameters, will return a list containing the input parameters of the algorithm. These parameters are then displayed on the Execution Controller tab in Net2Plan for the users to modify them before the execution of the algorithm. The third method, called initialize, is called once when the simulation starts, and it performs the initialization of the simulation, like reading the input parameters and initializing variables. Then the execute method is called each time the kernel wants a new set of demands. At each time slot during the simulation, the execute method will be called. It will generate a set of demands, and those demands will be returned as an array of doubles. We'll proceed now to review the code. As you can see, you have the getDescription method. It returns, as I said before, a brief description about the algorithm and any instructions that may be necessary as a string, and is then displayed on the Execution Controller tab in Net2Plan, as you can see here in this panel. Each time you select an algorithm, this description is displayed here. Next is the getParameters. It will return a list of tuple objects. In this case, a tuple is a set of 3 different objects, in this case 3 strings, representing the input parameters of the algorithm. For example, the first string, it's the name of the parameter. The second string is the default value. And the third string is a brief description of what the parameter does. Once these parameters are encapsulated as a tuple objects and added to a list, this list is returned to Net2Plan to be displayed on the Execution Controller tab, so the users may modify those parameters before the execution of the simulation. As you can see here, the parameters are displayed on this panel, and if you double click on any value, you can modify them. The third method, called initialize contains some input parameters. Those are the first, a Net2Plan object. This object encapsulates all the network design that has been loaded in Net2Plan. Here, this entire design, all the nodes, links, demands, routes, or protection segments that the design may have, is encapsulated in the Net2Plan object. The second one, called algorithm parameters, contains the input parameters that the user may have modified before the execution of the algorithm. Once those parameters that are here return to Net2Plan, so they are displayed and the user may modify them, they are then returned as the input parameters to the initialize method. The third one is the Net2Plan parameters. This contains a map of two strings containing the global options of Net2Plan. These options can be located in Net2Plan under the file options. For this example, we won't use any of them. As you can see in the initialize method, first of all, it checks if all the input parameters have a correct value. For example, the value CV must have a value greater than 0. If not, a Net2Plan exception will be thrown. This exception will be shown as a dialog error pop-up in Net2Plan. For example, we set a value of -1 to the CV option and try to run the simulation. You can see that the Net2Plan exception that is thrown by the initialize method is displayed as a pop-up error, as I said before. The same thing with the truncation parameter. Checks if it has a correct value, and if not, it throws a Net2Plan exception. Then it will generate a random seed, and it will extract from the Net2Plan object, that is the network design, an array containing the offered traffic in airlines as an array of doubles. And for last, the execute method. This method, using the original set of demands of the topology and the random object that has been created by the initialize method, will create, using the truncation parameters, a new set of demands for each instant. Then those demands will be returned as an array of doubles to the kernel of Net2Plan. I will proceed now to modify the basic traffic change generator. I will code a low-pass filter to be applied to every new set of demands. This low-pass filter will eliminate the peak demands, so the new set of demands don't differ so much from the previous set of demands. First, we will change the name of the algorithm, clicking on refactor, rename, and we will set it to the same name, -modified. I will pause now the video to perform some modifications. The algorithm has now been modified. As you can see, I have added 2 new variables. I will explain them later. First of all, the new getDescription of the algorithm now indicates that the algorithm also applies a low-pass filter to each new set of demands. Also, a new parameter called alpha with a default value of 0.5, it's a low-pass filter coefficient. And as you can see now in the initialize method, it also checks for the correct value of this new parameter. It also initialized the previous demands arrays of doubles with the offered traffic of the network design. This will be used by the low-pass filter. As you can see, I have added a system.out.println. Each print will be shown on the Java console. I will explain this later when we execute the algorithm during the simulation. You can use these prints, for example, to debug your code or to better control the flow of your algorithm. Now, during the execute method, you can see this part remains unchanged, but now with all the new set of demands, a linear low pass filter is applied, a simple filter with a alpha coefficient. The previous demands array is updated, and the new demand is printed in the console. And that's it, a simple modification of the basic traffic change generator algorithm. I will proceed now to test the modified algorithm. To do so, under the execution control tab, to load an algorithm, just click the load button, locate your Eclipse project folder, and under the bin subfolder, select the new modified algorithm class. So the basic traffic change generator -modified.class will open, and as you can see, the new description of the algorithm with its new parameter. For example, we will select the default value, and we just click on run the simulation. I will pause it, and well, if you click now on File, Show Java Console, you can see all the system.out.println that have been included in the code are shown here. You can see now the beginning simulation. This println was located on the initialize method, and each time a new demand is generated, it's shown here, as you can see. And now we can see that the algorithm works perfectly. I will explain now the basic traffic allocation algorithm, and I will perform some modifications to it. First of all, you can see that this algorithm implements the iTraffic allocation algorithm interface. We'll go to the Java doc, locate the iTraffic allocation algorithm. As you can see, this interface contains some methods that are equal to those of the iTraffic generator, like the getDescription, getParameters. Those two methods are exactly the same as the iTraffic generator interface, and the same thing with the initialize method. This method is called only once when the simulation starts. Now, the process event is called each time a new set of demands has been generated and must be processed. The finish transitory performs some transitory finished actions. This method will be not used in this algorithm. And the finish method returns an algorithm specific report. This method is called when you use this simulation report feature. You can collect your own statistics and then return them to be displayed on the simulation report. We will see about this later. Back to Eclipse, we can see the getDescription method. The getParameters has no input parameters, or in this algorithm, well, this method will remain empty. The same thing with the initialize method, since it's not required to initialize any particular variable, it will remain also empty. And since we have not collected any statistics, there's no need to display them on the simulation report. So also this method will remain empty as the finish transitory method. The most important one is the process event. You can see that this method returns a list containing traffic allocation action objects. It's important to note that during the simulation you cannot directly change the Net2Plan object, and since you cannot modify directly the network design. In order to perform modifications in your topology, you must create some actions, add them to this list, and then return them to the kernel of Net2Plan. Then the kernel will process those actions. So for each time slot, the process event method will analyze each route and calculate the demand that is carried by each route. Then it will create a new action using the traffic allocation action modify route method, including the route identification, the new demands, and the portion of that demands that is carried through that route. I will go to the Java doc to explain better the traffic allocation action class. This class allows to perform some actions that can modify the topology. For example, you can add, modify, remove any link, route of protection, or even SRGs to the topology. You can remove all the links or the routes, add, remove protection segments to particular route leads, and so on. To do so, this class has several static methods that allows us to perform such actions. So once all of the routes have been modified so they can carry the new set of demands, this list of actions is then returned to the kernel to be processed. And that's what this simple algorithm does. I will not pause the video and perform some modifications to the algorithm. Now that the algorithm has been modified, first of all, a new parameter has been added, capacity module, with a default value of 10. And each link requires an install capacity which is an integer multiple of this value. That means, for example, if we have 3 modules, the total capacity of that link will be 30. That means the capacity of the links of the net will be always a multiple of 10. That is because the algorithm now not only routes the traffic over the existing routes, but it will also calculate and set the capacity of all the links of the network as the equal or superior value of the traffic that each link carries. So once we can see this new parameter, the initialize method checks if it has a correct value, and it will also create an array containing all of the links of the network. Now the process event method, as before, it just puts all of the demands of the network through the existing routes, but it will also the traffic carried by this link is superior to the capacity of this link. If that is the case, it will then proceed to install new modules and calculate and modify the link capacity of this particular link. It will do so with all the links of the network, modifying the capacity of each link if required. Once it has done so with all of the links, if the user clicks on the update button on the simulation report, the finish method will be invoked. It has an input parameter called output. It's a string builder where you can append all the information you want to be shown on the simulation report. As the simulation report is generated as a HTML file, you can add HTML code to this string builder. As you can see, it will show all the modules installed in the topology and will also show the capacity of each link. We will test this algorithm now. To load the new algorithm, just select the allocation algorithm tab, click the load button, select the Eclipse project folder, the build subfolder, and the basic traffic allocation algorithm modified. As you can see, the new algorithm parameter, we will select, we'll let it as it is, a default value of 10, and now we can run the simulation. We'll pause the simulation, and if you go to the view current state, we can see now that the links have all a multiple value of 10 as their capacity. And the utilization of the links is always equal or less than 1. And if we go to the simulation report and you click on update, you can see now a new section called link capacity evolution. That is the string that the finish method returns, and the content of the string builder output is shown here. As you can see, it has calculated for each of the links of the network the number of capacity modules required and the total capacity installed for each one of those links. That's all. Thanks for watching, and please visit Net2Plan.com.